fluids in a formation are under pressure. When drilled, this pressure can escape to the surface if it is not controlled. Normally, drilling mud offsets formation pressure. That is, the weight or pressure of the drilling mud keeps fluids in the formation from coming to the surface. For several reasons, however, the mud weight can become lighter than is necessary to offset the pressure in the formation. When this situation occurs, formation fluids enter the hole. When formation fluids enter the hole, this is called a kick. A blowout preventer stack is used to keep formation fluids from coming to the surface. These are called BOPs. By closing a valve in this equipment, the rig crew can seal off the hole. Sealing the hole prevents more formation fluids from entering the hole. With the well sealed or shut in, the well is under control. Rig crews use a surface BOP system on land rigs, jackup rigs, submersible rigs, and platform rigs. They use a subsea BOP system on offshore floating rigs, like semi-submersibles and drill ships. A blowout is dangerous. Formation fluids like gas and oil blow to the surface and burn. Blowouts can injure or kill, destroy the rig, and harm the environment. Rig crews therefore train and work hard to prevent blowouts. Usually they are successful, so blowouts are rare. But when they happen, they are spectacular and thus often make news. A kick is the entry of formation fluids into the wellbore while drilling. A kick occurs when the pressure exerted by the drilling mud is less than the pressure in the formation that the drill string is penetrating. The mud that circulates down the drill string and up the hole is the first line of defense against kicks. Drilling mud creates additional pressure as it circulates. The mud pressure keeps formation pressure from entering the wellbore. On the rig, they say mud keeps the well from kicking. Sometimes, however, crew members may accidentally allow the mud level or mud weight in the hole to drop. This drop in weight or level can happen for several reasons. For example, the crew may fail to keep the hole full of mud when they pull the pipe out of it, or they may pull the pipe too fast, which can lower the bottom hole pressure. When the mud level or mud weight drops, the pressure exerted on the formation decreases. If either happens, formation fluids can enter the hole. If they do, the well takes a kick. In other words, when the formation pressure exceeds the weight of the mud column, then the well can kick. To keep a kick from becoming a blowout, the rig crew uses blowout prevention equipment. The blowout preventer, BOP stack, consists of several large valves stacked on top of each other. These large valves are called blowout preventer. Manufacturers rate BOP stacks to work against pressure as low as 2,000 pounds per square inch, or PSI. and as high as 15,000 psi. That's about 14,000 kilopascals. To over 100,000 kilopascals. Rigs usually have two kinds of preventers. On top is an annular preventer. It's called an annular preventer because it surrounds the top of the well bore in the shape of a ring, or an annulus. Below the annular preventer are ram preventers. The shut-off valves in ram preventers close by forcing or ramming themselves together. The choke line is a line through which well fluids flow to the choke manifold when the preventers are closed. Even though the preventers shut in the well, the crew must have a way to remove or circulate the kick in the mud out of the well. When the BOP shut in the well, mud and formation fluids exit through the choke line to the choke manifold. The manifold is made up of special piping and valves. The most important valve is the choke. The choke is a valve that has an adjustable opening. Crew members circulate the kick through the choke to keep back pressure on the well. Keeping the right amount of back pressure prevents more kick fluids from entering the well. At the same time, they can get the kick out of the well and put in heavier mud to kill the well. That is, regain control of it. The well fluids leave the choke manifold and usually go to a mud gas separator. A mud gas separator separates the mud from the gas in the kick. The clean mud goes back to the tanks. The gas is flared or burned a safe distance away. When the well takes a kick and the BOPs are open, well fluids force mud to flow up the well bore and into the BOP stack. When the driller closes the annular BOP, flow stops. Usually, drillers close the annular BOP first. The closed annular BOP diverts the flow of the choke line, which goes to the choke manifold. The driller can open a valve on the choke line and safely circulate the kick out of the well through the choke manifold. Here's an annular preventer. BOP closes on drill pipe, drill collars, or any shape of tubular in the well. It can also close on open hole, a hole with no tubulars in it at all. It's usually the first preventer used to close in the well. Here are 4 types of ram preventers: pipe rams, blind shear rams, and variable bore rams. Pipe rams are used when there is drill pipe in the BOP stack. The pipe rams fit around the pipe, closing off the annulus. Pipe rams back up the annular preventer. That is, in the unlikely event that the annular BOP failed, crew members could shut the pipe rams to seal the well. Also, some pipe ram preventers are used to hang off or suspend the drill string on subsea BOPs. Blind rams are designed to seal an open hole. If the annular BOP fails, and there is no pipe in the hole, the crew could seal the well by closing the blind rams. Blind shear rams are designed with blades that cut through the drill pipe and then seal the open hole. They are used in extreme emergencies, like when an offshore floating rig has to move off a well they're drilling because of a hurricane or other such emergency. Blind shear rams allow them to cut the pipe, seal the hole, and then move the rig a safe distance away. Variable bore rams, or VBR, are special pipe rams that can close over a range of pipe sizes, such as 5-inch diameter to 3-inch diameter.